Hey everyone, let's consider the same problem as the previous video. We have a graph y equals to e power x, right? Then we discussed that, well, let's say the region is R from 1 to 4, and we rotate it about the x-axis, and then we solve rotating it about the y-axis. But now let's change it up a bit. Alright, let's say the region is now from x equals to 0 to x equals to 2. Again, keeping this region R, but now the question is more specific, that we can only use this method, and we will be finding the volume after we rotate R about the y-axis 2 pi radians, right? Okay, so first thing first, as per usual, we'll be drawing lines to see whether we can use the appropriate method. So we notice that, okay, we can draw vertical lines downwards and we will encompass all the area of R. So we can use the shell method. However, the question wants this method, so there's definitely not a way that we can use it. Let's try using the horizontal lines then. Okay, now we realize that if we were to draw horizontal lines, most or all the area of R will be covered, but then we'll be including this extra area down here as part of our volume. And therefore, we need to do some subtraction, right? So what's going on, right? We cannot use this method to find the volume of R directly. So is there another way to consider about it? Very simple. We're going to rotate about the y-axis, and we have the limits, right? X equals to 0 and x equals to 2. We are rotating R about the y-axis, and we're using this method, and therefore the formula we have to use would be something pi integrating x squared dy, right? That means the limits must be in terms of y. So we cannot have x limits, we change it to the y limits. When x equals to 0, y e power 0 is simply y equals to 1, y x equals to 2, so y is simply e squared. So we know the limits are 1 and e squared. So we have 1, then we have e squared. Okay, so let's consider this region down here, right? Which, let's say we label this region P. If we were to draw horizontal lines, right, we notice that, hey, okay, it works, right? All the area in this region from 1 to e squared would be encompassed, right, through the lines. That means we can use this method to find this region P rotated about the y-axis 360 degrees, correct? But that's not what the question wants, right? We want to find the region R, but we can only use this method for region P. So what's the correct method here? First thing first, if you notice the region P and R, if you add them together, you get a rectangle, right? You get this rectangle here. What do you notice about this? Is that if we were to rotate the rectangle, again, about the y-axis, you find that volume, then you subtract the volume of P, you get back R, right? So you find the volume of rectangle rotated minus away the volume of P rotated, you get back the volume of R, right? Rotated. Alright, so this is the idea that we're looking at. So sometimes when you realize that you cannot use the method on the region, you need to consider another region and then taking it as a rectangle or taking it as a square. It really depends on the values that they give you. Alright, so in this case, you know that this method can only be used to find the region P, which is outside of R. But if you notice that if you add P and R together, you get a rectangle. And if you rotate a rectangle, what do you get? So you rotate a rectangle, so it's like a rectangle, then you spin it 360 degrees, right? And you get this, right? You get a cylinder. Alright, so you get this, you spin it 360. Let's say this is the y-axis. So yeah, you get a cylinder, right? So you get a cylinder. Let me just draw this nicely. Okay, so how do you find the volume of a cylinder? Again, right, it's like a volume of a disk, right? So R, your height, so it's basically pi r squared h. In this case, what is the volume of the rectangle? the volume of the rectangle is simply pi. R is 2, right? Because you notice that the radius from here to here is 2, right? Because 0 to 2. So 4, right? 2 squared is 4. What's your height? Your height is from here to here. So from here to here, which is e squared. So we have 4 pi e squared. All right. Now we find the volume of the rotated p about the y-axis. So again, we have pi x squared dy. The limits are 1 and e squared. Now we solve, right? Factorizing out pi, we have 4e squared minus away. Integrating 1 to e squared, x squared would be ln y whole thing squared dy. Okay, because if you have y equals to ex, you take the ln, you get ln y equals to x. Now we perform our integration by parts, right? Because there's no clear way to integrate ln y squared directly. So we integrate 1 to get back y ln y squared, putting our limits 1 and e squared. Minus minus become plus, so plus sign. I differentiate ln y squared. So if I differentiate ln y squared, okay, let's say d dy ln y squared, I would get back, well, simple, bring out the power to the front, reduce the power by 1, and then differentiate inside. So get 2 ln y over y. Because I have to multiply by the original y, right? The y extra, so I get back 2 ln y. As a result, I would get integrating 2 ln y 1 e squared dy. Okay, now add the limits for the first part of the integration by parts that I did. So I'll get y, substituting e squared, I'll get back e squared. Ln e squared is basically 2, right? So 2 squared will become 4, 1. So if I substitute y equals to 1, it will be ln 0. Ln 1 equals to 0. So there'll be 0. So I'm done for the first part. Now I look at integrating ln y, right? Now same thing here. You can't integrate ln y directly. So we again perform the second integration by parts to give you back y ln y minus sine 2 integrating 1 e squared. Now differentiate ln y, you get back 1 over y. 1 over y times y will give him back 1 dy. Okay, let me just write this below. Minus 2 integrating 1 e squared 1 dy. Okay, now here comes the last part. It's just basically putting your limits and then well, just simplifying, right? So I get 4 e squared minus e squared, so this give me 0, so simple enough. Now I get 2y ln y, so I get 2 e squared times another 2, so this will give me 4 e squared. Again, ln 1 equals to 0, so he gives me back 0. Minus away, integrating 1 will basically give me back y, so I'll get minus 2 e squared plus back 2. Alright, then I will get 2 pi e squared plus 1 units cube. So there we have it. Using the cylinder to help us to find the volume of a region when we cannot actually integrate to find the volume of the region directly. So in this case, if we use this method, we can't, right? But we can only use the shell method to find the volume directly, right? And you should do that, right? Especially if you want to check your answer. So let's say you want to check your answer, right? It's basically using the shell method from x equals to 0 to x equals to 2. And the formula is 2 pi xy dx, right? So xy will be x ex dx. Then you do the integration by parts again. So you integrate ex first. You get back x ex 0 to 2 minus away 2 pi, because obviously you follow the 2 pi around. Minus away, now you differentiate x to give me back ex. Then lastly, you just simply put in the limits. Minus away e squared plus 1. Okay, so it's e squared. I did a lot of skipping the steps, right? I mean, you can solve this on your own, but ultimately you would get back the same answer. Okay, so again, this is not limited to the disk method only. This is also possible for the shell method, especially when it comes to considering the cylinder. So yeah, this is the second example of the disk versus shell when you're talking about considering a cylinder.